Okay guys, today we'll be taking a locus question based on complex number, and you can see that the question says that if z1 and z2 are two fixed points with z being a movable point in the Argand plane, find the locus of the point z if under the condition modulus z minus z1 divided by modulus z minus z2 is equal to m, where m is a positive quantity and m is not equal to 1. So we can see that the condition says modulus of z minus z1. So according to the figure, you can see that I have taken two fixed point a and b. Okay, so a is the point z1 and b is the point z2 in the Argand plane, and p is a variable point which is z. So according to the condition, it is modulus of z minus z1, that is the distance between p and a, divided by the distance between z and z2, that is the distance pb. So pa by pb is given to be a positive quantity m. So we can safely write down pa by pb to be equal to m, where p is a variable point. Now what I've done here is that I've done a small construction, like I've joined pa and pb. Now for the angle APB, if I analyze, if we consider the internal angle bisector of angle APB, so PC is the internal angle bisector. So according to the geometrical property, we know that internal angle bisector will divide the side AB of the triangle APB in the ratio of the other two sides. So safely we can write down that CA by CB, this ratio is also going to be equal to m, because geometrically we know that CA by CB is nothing but PA by PB. So CA by CB, this value can also be said to be m. Okay, so C is the point that is basically bisecting internally the line segment, not bisecting, rather intersecting AB internally in the ratio that is m is to 1. So we can write down the coordinate of the point C to be equal to, so we can safely say that C will have the coordinate, that is, we know CA by CB is m is to 1, the ratio is m by 1. So we can write down the coordinate of C to be m z2 plus z1 divided by m plus 1. Okay, using section formula we can get the coordinate of the point C very easily. And similarly we can see that for the angle APB, if I consider the external angle bisector, so PD is the external angle bisector of APB, and again according to the geometry, then external angle bisector divides the base of the triangle externally in the ratio of the other two sides. So safely we can also write down that DA divided by DB, this ratio is also going to be m is to 1, because D is going to divide AB externally in the ratio m is to 1, that is PA is to PB. So we can similarly get the coordinate of the point D using the external division formula. So we can safely write down the point D to be having a coordinate that will be mz2 minus z1 divided by m minus 1. As you know, this is the formula for external division. So once we get the coordinate of C and D, now we can analyze that this is the internal angle bisector of APB and this is the external angle bisector of APB. So the internal angle bisector and external angle bisector will be inclined at an angle 90 degree according to the basic geometrical property. So this particular angle CPD, this should be 90 degree, and as you know that C is dividing AB in the ratio like m is to 1, so CA by CB is m, so definitely C is satisfying the condition of locus, and similarly DA by DB is also m, so D is also satisfying the condition of locus. So we can say that C, D and P, all of them should be lying on the same locus because they all are satisfying the condition that is given in the question. So we can say that C, P, D, all of them should lie on the locus, and since we can see that this angle is 90 degrees, so we can say that these 3 points will be lying on a circle. So this is going to be the locus path. You can see that the locus path is going to be a circle with CD as the diameter, okay, because CD is subtending an angle 90 degree on the circumference of the locus circle. So you can see that we have got the coordinate of C, we have got the coordinate of D. So very easily we can get the circle equation, which is going to be the path. So we can say that this is going to be the locus. So locus is a circle with CD as diameter. So C and D, which points, the points we have already got the coordinates of C and D. So CD will be the diameter of its circle, and that particular circle equation we can easily find out. So CD will be the diameter of the circle, and that circle is going to be the locus of the variable point Z. Thanks a lot. Bye bye.